Alright, so clams are mollusks. So, just like your bell work, a mollusk is a soft-bodied animal with an internal or an external shell. The one that we're going to dissect, a clam, has an external shell. If you ever want to eat like a clam or an oyster or a scallop, you have to open that external shell so that you can eat the muscle on the inside of it. Our representative organisms, or another word for that is, if you want to put this out beside there, these are just examples of mollusks. That's the fancy name for clam. These are things like snails, slugs, clams, oysters, squid, octopus, scallop. The one we're going to dissect, go ahead and underline a clam. Now, their type of skeleton, our clam, is an exoskeleton. Remember, if you have an exoskeleton, where is it? On the inside or the outside? Outside. So go ahead, write yourself that note. Hey, this is on the outside. Their skeleton is their shell. And their type of symmetry, how we divide them, is bilateral. Remember, put yourself the note that you can divide this animal. Divide. You can put down the middle or in half. Either one of those is perfectly fine. So a mollusk, a clam. So these are some of the things you need to know for your quiz about that clam. We're going to know some of the big major parts of the clam. So whenever you're dissecting next week and you kind of look at that organism, you won't be thinking, I don't know what any of this is. You need to know, hey, this kind of looks familiar. So how do clams move? They do have a gigantic muscle, they do.
They open their mouth.
So if they want to be able to eat something, or if they need to move and get away in a hurry, they have to open up their shell. So remember, their skeleton's composed of a shell. If you are an animal and you have two shells, you're called a bivalve. So underline that. This is what a clam is. A clam is a bivalve.
Is the shell like on top of them?
It has a shell on the bottom that holds the muscle inside of it, and then it has another shell that sits on top of the muscle to protect it from things eating it. So that's why it needs two shells. So one of the big things to be able to keep that shell closed so things won't eat the clam, you have two adductor muscles. They hold the two shells together so the clam can open or close. If it wants to open its mouth, it's usually because it's hungry. It closes up if it sees a predator. If something wants to harm or hurt or want to eat that clam, it is going to close its shells and very, very tight. To where usually things won't want to bother it because they're thinking, oh, I don't want to take that time to, try to pry open that clam. But if that clam is hungry and there's nothing there to kind of, bug it, it's going to kind of open up.
Can't they lay pearls?
We're going to learn how a pearl works, actually, in just a second.
Yay.
Depends on how big it is. You can.
It's like pearl.
Alright, anybody still underlining this? Alright, so parts of the shell. If you're a clam, you got a couple of parts. The umbo, we're going to look at a picture of this, but I want you to get your writing stuff down first before I show you the picture. So, there's something called an umbo. It's a swollen part where the two shells come together. There's something called a cardinal tooth inside the shell. It's pointed. There's something called a hinge tooth that helps the shell stay closed. It's kind of long and flat. It's got a horny outer layer. They're like growth rings on the outside. They're rough. It's kind of like a tree. To know how old a tree is, you count the rings. To know how old a clam is, you count the rings.
What about a person? Can you do that too?
And then the pearly layer, that kind of shiny layer, put out beside pearly layer, put that it's shiny. This is the shiny part of the inside of the shell that sometimes you see. So how do you make the shell? That shell is made from secretions, and kind of like you have glands that are in the mantle, and we'll talk about the mantle. The mantle is this kind of thin membrane, and it covers the mother of pearl layer. Alright, so anybody still getting their little notes down? So that mantle is a thin membrane. It covers, or it sits on top of that shiny mother of pearl layer. And this is what it looks like. You do not have to draw this. This is just to show you. So this is the shell. There is a hinge tooth. It kind of sits kind of toward the top of the shell. It's kind of long and thin. This is the umbo. It's kind of the swollen part where the two shells meet. There's the cardinal tooth. It's right there. It's kind of pointy.
Wait, do the shells eat or sleep?
No, the shell is just there for protection.
Why do they call it teeth?
Well, they say that it's kind of like teeth. They compared it to teeth, which means it kind of helps with the opening and closing of the shell. Whoever discovered this first, they said it looked like a tooth to them, so we kept it.
So that's the mother of pearl?
So the mother of pearl layer is this kind of shiny layer right here. The two adductor muscles, they're right here and right here. They've been removed so you can see the other parts of the shell. This kind of membrane right here is the mantle. It sits on top of the mother of pearl layer, and it helps secrete kind of and makes that shell. The outside of it, so whenever you first look at your clam, you're going to see the umbo. That's that kind of curved part. Remember growth rings on the outermost layer? If you counted all these teeny tiny little rings, then you would know how old that clam was.
Miss Ronnie, can you get money by selling those?
So if you make them into jewelry, you can make money selling them. But they have to be very colorful, and they have to be...
The beach and this kid had like a big bucket of everything because
So this is how a pearl is formed. This is usually the big question I get. So what happens? Natural pearls. And if you go to buy some pearls and they say this is a cultured pearl, this is how that pearl is formed. So something called an irritant, which could be a variety of things, like maybe a pebble or maybe a grain of sand or a microscopic worm that's so tiny we can't see it. What it does is it gets caught between the mantle, this kind of membrane right here, and the mother of pearl layer. It kind of the clam probably opened its mouth to eat something, and then that grain of sand or a teeny tiny pebble got caught underneath there. And so it's kind of irritating the clam. It's kind of like having a rock in your shoe. Think about if you've ever gotten something like a leaf, like a pokey leaf, or usually a rock in your shoe. It's uncomfortable. So what the clam does is it gets the mantle. It's got mucus glands inside of it, and what it does is it coats the irritant for many years. And that's where you get a pearl. That pearl is just a bunch of mucus that's covered up like maybe a pebble or a grain of sand.
How much do you think that's worth?
That pearl, if it's a natural pearls just occur in nature. You don't, force feed a clam grains of sand and make them create pearls. A natural pearl, usually about that size, would probably be about $80. Alright, so the foot, probably the most fascinating part of the clam. So all a foot is, think about what you use your foot for, to move. So the foot is just a big muscle. So put it out beside there. It's just a big muscle. That's all it is. It's a big muscle. And what it's used for, it's for movement. You can either dig into the sand to hide from things, you're going to anchor somewhere if a storm's coming, or you move. Your type of movement is you hop, and I'll show you a video of this later. Alright, so how do clams and all kinds of mollusks reproduce their fertilization? It is external and it's in the water. So remember, external, if you need to put yourself this note, outside the body. And then occurs in the water. Now, the type of sexes, those are the genders. Here's the deal. With clams, because they're clams and they live in the ocean, they are something called monoecious. Mono means one, which means that they have both male and female organs. Therefore, they can have a lot more clams. Their trachiophores are their free-swimming larva stage. Those are baby clams. They're microscopic. They just look like a white little pebble floating in the water.
Alright.
And then those trachiophores will grow up so big, and then they'll start creating a shell on the outside. And then there'll be an adult clam. Alright, feeding. So just kind of to hit the highlights. Purpose of any kind of animal feeding is to get nutrients so it can grow and make energy so it can live. Clams are filter feeders, which means that they filter the water for food. They kind of open up their shells a little bit, let the water come in. It'll filter out all the microscopic food, and then it'll spit the excess water out. Now, they have these things called labial palps. They direct food into the mouth. They're kind of like lips. They make sure that the food doesn't fall out of the mouth. So, if you want to put that beside there. Alright, so just to kind of give you a preview of what we're going to label in just a minute. We've already talked about some of these, like the adductor muscles. They help keep the shell opened or closed. The mantle, that nice thin membrane. This is what the clam's mouth looks like. It's very small, teeny tiny opening. It's about the size of a pinhead. And then these are the labial palps right here. Those are kind of like the lips. They direct the microscopic food into the mouth so it can eat. There's the foot that's going to help it move around and hop. I'll show you a video of that later. And then gills. What do you think they use those gills for?
To swim. Breathe.
Definitely to breathe.
Because fish use their gills to breathe.
Alright, so internal transport. How do they get nutrients to every part of the clam? So type of circulatory system they have is they have an open circulatory system. Some animals have an open circulatory system. Some have a closed one. So if you have an open circulatory system, your blood does not flow through blood vessels. The rate of blood flow that you have, how fast your blood flows, is very slow. The only type of animals that need them are slow-moving things like clams. They don't move very often. They find somewhere, they attach, and they usually live there for a while. Why? Because they're not moving that much, they don't have to require a bunch of energy. Now, the function of any heart, because clams do have a heart. Any heart pumps blood. The type of heart it has is simple. Whenever you look into your clam and you dissect it next week, you're going to find the heart, and the reason you're going to find it is because it's going to be kind of a bluish-green color. The reason why? It's got this chemical that's very different from ours. Our blood is red whenever it hits the air. whenever their blood hits the air, it's still blue because it has this funny chemical in it because they live in the ocean called hemocyanin.
That was like green, like before you.
Alright, respiration. Their respiratory organ, like anything that permanently lives in the water, gills. And it's just enclosed or below or beneath that mantle. That mantle covers up their gills to protect it. Alright, so alright, on to our labeling. Out beside each letter, A, B, C, D, and so on, please write the name, or if you want to just list them, A, B, C, all the way down, and write the name out beside it, whatever works for you better.
Can we do both?
You may do both if you'd like to. So, the umbo, it's on the outside. It's that swollen part. Gills, they actually sit right here. They have these kind of little ribs on them. Now, what do they use the gills for again?
Breathe.
To breathe. They have adductor muscles. One of them's here. One of them's there. What is it that they use the adductor muscle for?
Foot.
Close and open the shell. Very nice. Then you have this thing called a siphon. That's just to help bring in water and kind of spit out water. I just wanted you to know, hey, whenever you look inside your clam, if you see that, you'll kind of have an idea. There's the mantle. It's that nice thin layer. You have this thing called a visceral mass. Visceral mass has all, put yourself a parenthesis, and that's where all the organs are. Like its heart, its stomach, its intestine, everything is in that visceral mass. That way, whenever we go to lab, you'll kind of have an idea of what you're looking at.
Under the foot.
And then for foot, it's this guy. That's that kind of, he kind of looks like a tongue shape. And remember, he's a muscle. And what do they use that foot for?
To smack.